AOPS number theory 5.13. Find the number of positive divisors for each of the following. A. 18. So the formula for the number of positive divisors for any number is so if the prime factorization is prime 1 to the power of e1 times prime 2 to the power of e2 times prime 3 to the power of e3 and so on to prime n to the power of en, then the number of positive divisors would be e1 plus 1 times e2 plus 1 plus e3 times e3 plus 1, etc. to en plus 1. So for the first one, which is 18 is equal to 2 to the power of 1 times 3 to the power of 2. So the number of the positive divisors would be 1 plus 1 times 2 plus 1, which is 2 times 3, which is 6. So for B, 52 is equal to 2 squared, 2 to the power of 2 times 13 to the power of 1. So the number of positive divisors would be 2 plus 1 times 1 plus 1, which is 3 times 2, which is also 6. And C is 216 is equal to 2 to the power of 3 times 3 to the power of 3. So the number of positive divisors would be 3 plus 1 times 3 plus 1 times 3 plus 1, which is 4 times 4, which is 16. 420 is equal to 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 1 times 7 to the power of 1, and if you do the same thing, it's 24. 2520 is equal to 2 to the power of 3 times 3 to the power of 2 times 5 to the power of 1 times 7 to the power of 1. So yeah, you do that, it will be 48. And 3,750 is 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 4, which is 1 plus 1 times 1 plus 1 times 4 plus 1, which is 2 times 2 times 5, which is 20. Find the AOPS number theory 5.14. Find the number of distinct positive divisors of 30 to the power of 4, excluding 1 and 30 to the power of 4. So 30 to the power of 4 is equal to 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 1 in brackets to the power of 4. Well, that's equal to 2 to the power of 4 times 3 to the power of 4 times 5 to the power of 4. So if you want to find the number of the positive divisors, then you would do the exponents plus 1 multiplied together. So the first exponent is 4, so 4 plus 1 times another 4 plus 1 times 4 plus 1, so that's equal to 125. So since it says the number of distinct positive divisors excluding 1 and 30 to the power of 4, then you would subtract 2, so 125 minus 2 is 123. AOPS number theory 5.15. Joseph and Timothy play a game in which Joseph picks an integer between 1 and 1000 inclusive, and Timothy divides 1000 by that integer and states whether or not the quotient is an integer. How many integers could Joseph pick such that Timothy's quotient is an integer? So if you want the quotient to be an integer, then the number must be a positive divisor of 1000. So if we prime factorize 1000 to 500 to 250 and 125. Oh, whoops. 5. Yeah, so 1000 is equal to 2 to the power of 3 times 5 to the power of 3. So if you want to find how many integers would be a positive divisor, then you would do exponents plus 1 multiplied together. But the two exponents is 3 and 3. So you do 3 plus 1 times 3 plus 1. So that's the number of divisors of 1,000. So that's equal to 4 times 4, which is 16. So Joseph could pick 16 numbers that would make the quotient an integer.